Hello, my name is Carl Fawcett, and I'm the inventor of the airfoil generator. In this video, I'll share with you just a few of our over 400 different tests on this unique wind generator design. Each test was done to show the results of a single item that we were trying out in our pursuit of the optimum setup. These tests were performed in computational fluid dynamics, or CFD, and each test would typically take between 4 and 7 days. Then we would examine the results, make our changes, and test it again. Here are a few screenshots from the last 2 years of development. This screenshot does an excellent job of showing you exactly what all the fuss is about with an airfoil generator. It's the wind speed that determines how much energy there is in the air, and the airfoil makes higher wind speeds out of lower ones. In this screenshot, the airfoil is being tested without a turbine to help us identify where the area of greatest velocity gain is. The wind coming to the nose of the airfoil is flowing at 10 miles an hour, but by the time it reaches the top of our airfoil, it's now going 16.3 miles an hour. Here we've changed the shape of the airfoil and found a little more, making an 18.3 mile per hour wind from that same 10 mile an hour breeze. So how well does this work in higher winds? We tested for that too. In this picture you can see that the ambient wind approaches the airfoil at 15 miles an hour, but it's been more than doubled to 32 miles an hour now. Because the power in the wind increases at the cube of the wind velocity, this doubling of the wind speed has created 8 times more kinetic energy for us to draw from. The benefits of the airfoil are real. These are a few of the very first tests, before we had learned what the best shape of the airfoil would be and where the turbine should be located within it. Because this was an all-new design, we had nothing to go on, and everything had to be tested and measured. Then we tested to discover how many blades the rotor should have. 3, 5, 7, or even more. For us, the sweet spot turned out to be 5. I remember this surprised us because it's counterintuitive. Without testing, you might assume more vanes would be better. You may have noticed by now that not all the tests turn out great, but that's kind of the point of testing, isn't it? So I've included some of the bad results as well as the good ones here, so you can get a truer sense of the development process. These screenshots are from some of our angle of attack testing. We had designed the airfoil generator with the belief that keeping the angle of attack to 0 degrees would be best, but we ran a sequence of tests anyway, just to make sure we were right. The shape of the airfoil after the turbine has been a very important item for us, so we've tested different designs of it a lot. It provides us with benefits in air velocity and pressure differentials, but its best trick is to turn the turbulent air after the rotor back into a smooth laminar flow again. The airfoil also makes the wake behind the generator as turbulent-free as we can make it, which has benefits in noise reduction and other environmental advantages. Now let's look at some pressure porting screenshots. We felt there had to be a way that we could benefit from the pressure differentials on each side of the airfoil, but finding how to use them to our advantage took a long time and many tests, moving the inlet location and then the outlet into the turbine housing. After a lot of experimentation, we did find just the right setup that works well. We took another deep dive into the shape of the blades themselves, and here are a few screenshots of that. I have 2 patents on impellers for superchargers, and the knowledge from those experiences was useful to us here in developing the optimum rotor. All the testing we had done up to this point was with straight rotor blades. Now it was time for us to work on a helix or a twist to those blades to reduce torque surge, vibration, and noise. Finding the right amount of twist wasn't easy. I'd call this section putting it all together, if I had to name it. There are so many relationships between the parts of this design that a change to any one part had an effect on several. CFD testing was the only reasonable way to run many iterations back to back to back to separate the best ideas from all the others. Once we got the single airfoil to put out good, reliable performance figures all the time, we moved into the twins concept. I knew that the proper positioning of two airfoils could create a venturi between them, which would make the output greater than two generators alone. It does. But it took many, many tests to find that sweet spot where it really produces. I hope you found this interesting and informative, if only to help you understand how many variables there are and how each had to be tested singly. The current design is very good and it's ready to be built, but it isn't done. It will never be done, really. There will always be an adjustment here or a new technique or material there that will make our design better. So even now, we keep engineering and testing to find them. Thank you for watching.